In this video, we want to evaluate this 3x3 determinant. Now, a determinant is simply a number associated with a square matrix. It does have to be a square matrix, otherwise you can't have a determinant. So 2x2, 3x3, 4 rows, 4 columns, and so on. And we're going to look at several methods to evaluate the determinant. The first one we're going to look at is involving cofactors and minors. Then we'll look at some shortcuts. Also a property of determinants. So first remind you that if you have a square matrix, say A, B, C, D, that's the easiest one to evaluate. So 4 components, 2 rows, 2 columns, A, B, C, D. And then if this is your matrix, then we denote the determinant by putting it in this form, looking like absolute values, but they're just a way to denote the determinant. And then we just cross multiply AD and then subtract the other product. So cross product this way and the other way, and then BC. And this of course would be a number, because these will be values you combine. Now for a 3x3, there's several ways to do it. There's a method involving expansion, which deals with cofactors and minors. Let's look at any, you can look at any row or any column. So let's look at the first row. The first entry in the first row is -1. And every entry in either any row or any column has what is called a cofactor. Now the cofactor simply involves what is called a minor. So I'm going to denote it's going to be a determinant. What you do is you take away the row that the entry is and the column, and whatever is left is your minor. So in this case we have a -3, 4, 5, 0. So the minor associated with -1 is the 2x2 determinant, -3, 4, 5, 0. And again, the minor is simply obtained by removing or eliminating the row that the entry is and the column that that particular entry is. Whatever is left gives you a 2x2. In the same way, if you're dealing with a 4x4, when you do this procedure, you'll be left with a 3x3. So in that case, the minor will be a 3x3 for 4x4. And then the only thing you have to do now is the minor is multiplied either by a 1 or a -1 to get what is called the cofactor. And how you determine that is you look at the row and the column that the entry is. So in this case, -1, and then we put a -1 in parentheses over here. This -1 is not this -1. This is going to determine what you multiply by. So you simply add the position of that. It's in the first row and first column. You add those up, and that's 2. And you simply take -1 to the second power, and that's a 1. So these exponents are either going to be even or odd. So if you take -1 to an even power, it's going to be a +1. You take it to an odd power, like say 3, -1 to the third is negative. That's going to determine what sign this is. In this case, -1 squared is 1. So this is multiplied by 1. And this would be your cofactor. So the procedure then for calculating or evaluating a 3x3 determinant is you can pick any row you want. There's 3 rows. Any column you want. In this case, again, we're dealing with a 3x3. There's 3 columns. So there's 6 ways to do it right there. You always want to pick the row or column that has the most zeros, because what you're going to do is you're going to take every entry in the row or column that you pick and multiply it by the cofactor of that entry. And that's why you want the one with the most zeros, because 0 times anything is 0. But just to illustrate the procedure, I'm going to pick row 2 and expand it. So here's row 2. So here's the way it's going to work then. Going through, you see those elements. You see 2 there, you see -3 here, and you see 4 here. So all we're doing then is computing the cofactor, and that's going to multiply the entry. So in this case, 2 is in the first column, or let me say second row, first column. Add those up, 2 and 1, that's 3. So this is going to be a -1. So this part right here, that's your cofactor for that one. So I said eliminate the row and the column that entry is in. Whatever's left gives you the minor. So there's 1, -2, 5, 0. And this is how we get this part right here. Then we go to the next entry, -3. There's the -3. And that's in the second row, second column. 2 and 2 is 4. That's even. That's why this is a positive 1 here. And there's, take away the row that entry is in the column. What's left? -1, -2, 0, 0. That's how I get this part right here. And that completes that. Now the next entry is 4. So there's the 4 right there. And that's in the second row, third column. Second row, third column. So eliminate the row and the column. And of course it's 2 and 3 is odd. So that's why I have this -1 here. This will multiply the entry. And then of course whatever's left here after I remove the row and the column, I get -1, 1 and 0, 5. Now it's expanded. All we have to do now is compute this out. So for a 2 by 2 here, this is what we have here. 1 times 0 is 0. So it's 1 times 0 is 0. And then you subtract the other product. So the other product is -2 times 5. That's -10. Subtracting that gives me a +10. And then the -1 times the 2, we get this. For the next one, cross multiply here to evaluate the 2 by 2 is 0. Minus the other one is also 0. So I'll get -3 times 1 is -3, and this times 0. So that's going to cancel out. And then we get to the other one, -1 times 5. -5 minus 0 is still -5. And here I have a -4 here times a -5. That's a +20. Minus 20 and a +20 is 0. That's the value of the determinant using the expansion. Let's go back to this one then. And I mentioned that what you want to do is pick the row or the column that has the most zeros. So what you want to do in this one then is pick the third row. Because here's what you're going to have. It's going to be 0 times the cofactor, but that's just 0, so don't mess with it. And then 5, of course, times the cofactor, and then 0 times the cofactor. Add those up. Well, the first and the third are 0. So the only one you have to mess with is the second one. So there's the 5, the entry, and then take away the row and the column. What's left will be your minor. So that is going to be -1, -2, 2, and 4. And then this is going to be times right here. That's going to be always going to be either a 1 or a -1. And you can see from the first part, the signs are going to alternate. Once you find the first one, they alternate. Here we just need 1. So this one's going to be, we're down 3. It's just in the third row, second column. 3 and 2 is odd, so this should be negative here. So it's going to be -5. But here it's not going to matter, because when we do this calculation here, 4 times a negative, to evaluate the 2 by 2, 4 times a -1 is -4. And then it's minus -2 times 2, that's a -4. So this will be a +4 and a -4, 0 times -5. We get 0. And there you have it. So this is the way you want to do it. If you're doing the expansion method here using cofactors and minors, always pick the row or the column that has the most zeros. Makes it easier to work. Now, there's another procedure that you can use, and this one only works for won't work for 4 by 4s and higher. So here's what we do for that one. For a 3 by 3, okay, we did it a couple of ways here. Here's another way. What you do is you take the first two columns, column 1 and column 2, and put them to the right. You got -1, 2, 0, 1, -3, 5. And then what you're going to do is you're going to cross multiply here. Start at the upper left over here and multiply these entries. Here and here. So it's -1 times -3 times 0. That's going to be 0. So these you're going to add. It's going to be plus. And then we got 1 times 4 times 0. Well, that's 0. Plus. Here we go. -2 times 2 times 5. That's -20. So you have the cross products from the upper left here, you add those. And then you have the cross products going the other way. These are going to be all subtracted. So I'm just going to put parentheses and a minus in front here. So it's going to go the other way. So you're going to start here, go up. So it'll be 0 times -3 times -2. Well, you got 0, so that's going to be 0. Then we'll go to the next one. 5 times 4 times -1, that's 20, times -1, that's -20. And then finally the last one here, up the diagonal here, 0 times 2 times 1. Because you're multiplying by 0, that's going to be 0. So for the first products, I get -20. And for here, I get a -20 and then a minus, has to be a +20. So this is going to go to 0. That's another way you can do this. Another way you can do it. So again, for this one here, we have 6 rows. I'm sorry, 3 rows, 3 columns. So there's 6 ways to do it there. But I would just use the one we just finished. And then of course there's that shortcut, that's 7. And there's sometimes you can use properties. Now there's several properties, and I'm going to do another video on that strictly in properties. But one of the main properties that you need to know is anytime you have a determinant and you have one row or one column where all the entries are 0, the answer is always going to be 0. You expect to get 0. And then another one you can use also is anytime you have a determinant and you have 2 rows that are multiples of each other or 2 columns that are multiples of each other, the answer is always going to be 0. So if you're working a quiz in class and your instructor tells you to evaluate the determinants, show your work, whatever procedure you're going to use, and if you're using properties to just indicate the property, well, here's one. You can see that the first row, the first column rather, -1, 2, 0, -2, 4, that's a multiple. They're multiples. So if I multiply the first column by 2, I get the second one. So the answer to this one using this procedure is equal to 0, and the reason would be because column 1 and column 3 are multiples of each other. And we'll have a few more videos on determinants here, but for now this will be the end for this particular video. Thanks for watching. We'll see you next time.